For example 4, which of the following lines are perpendicular to the line 4x minus 2y plus 9 is equal to 0? Well, I'm going to rearrange that and say that I have negative 2y is equal to negative 4x minus 9, or y is equal to, when I divide everything by negative 2, 2x plus 9 over 2. If it's asking if it is perpendicular, then if in my original equation I have a slope of 2, I'm looking for ones that now have a slope of negative 1 over 2. So I'm just going to turn all of these into slope y-intercept form and look for which ones match. Here I'm going to say I have 3y is equal to negative 6x plus 1, or y is equal to, when I divide everything by 3, negative 2x plus 1 over 3. This one does not match. In the second case, I'm going to say that 2y is equal to negative x plus 12. When I divide everything by 2, y is equal to negative 1 over 2 x plus 6. This one has a slope that I'm looking for, so this one is perpendicular. And in the last case, 10y is equal to negative 5x. When I divide both sides by 10, I'm going to get negative 5 over 10x, which can get reduced down to negative 1 over 2x. And once again, this one has the slope that I'm looking for. This one is also perpendicular. For example 5, it says, write the equation of a line which is perpendicular to 2x plus 5y minus 7 and has the same y-intercept as 2x plus y minus 6. Well, the first thing is I need to find the slope from the first one to figure out if it's going to be perpendicular. So I'm going to say that if I have 5y is equal to negative 2x plus 7, then y is going to be equal to negative 2 over 5x plus 7 over 5. If this is the slope of the original one, the slope of the one I'm looking for is going to be the negative reciprocal because it's perpendicular. I need a slope of 5 over 2. I'm going to get my y-intercept from the second one, and I'm going to say that if y is equal to negative 2x plus 6, then there's my y-intercept that is going to match. Now I want to state my answer in both slope-intercept and in general form. For slope-intercept, it's going to be y is equal to 5 over 2x plus 6 and then I'm going to do the same process we did for the first questions in order to turn it into general form. Because the x is positive, I'm going to move the y over there and say that 5 over 2x minus y plus 6 is equal to 0. And then to get rid of the fraction, I'm going to multiply everything by 2. 5x minus 2y plus 12 is equal to 0. And there's my general form. A student made the following statements about a line with the equation 2y is equal to 5x plus 12. Statement 1, the line has a slope of 5. Statement 2, the line is parallel to 10x minus 4y plus 13. And statement 3, the line passes through the point of -2 and 1. Well, if I'm going through and looking for the true statements for what I see here, the first thing I'm going to check is what is the actual slope in this case. Well, I see that I have a 2 beside the y, so I'm going to divide everything by 2, and this equation is actually going to become y is equal to 5 over 2x plus 6. There's a true form of my slope-intercept. As soon as I do that, I can see that statement 1 is false. The slope is not 5, the slope is 5 over 2. It says it is parallel to 10x minus 4y plus 13. Well, let's take that 10x minus 4y plus 13, and we're going to isolate y. Negative 4y is equal to negative 10x minus 13, or y is equal to, when I divide everything by -4, negative 10 divided by -4 is the same as 5 over 2 x plus 13 over 4. Here's my slope. It matches the slope of the original one. Because the slopes are the same, it is parallel, and that is true. And for the last part, when it says that it passes through the point of -2 and 1, I'm going to take my original equation and replace the x with 1 and the y with -2 and see if that equation balances out. So I'm going to say that 2 times -2 is equal to 5 times 1 plus 12. Oh, sorry, I did those backwards. 2 times 1 is equal to 5 times -2 plus 12. 2 is equal to -10 plus 12. 2 is equal to 2. It balances out. That statement is also true. So, which of the above statements are true? The answer is C. 2 and 3 are both true.